So welcome to the 17th lecture, Mathematics for Machine Learning. In the last lecture, actually last week, we completed two modules. क्या क्या किए थे हमने? Matrix decomposition and vector calculus. Yeah. So the idea was to revise those concepts and then also generalize them to matrices and vectors. Yeah. तो अब यह है कि वन यू सी दैम इन योर पेपर्स, रिसर्च पेपर्स में आप देखेंगे ग्रेडियंट्स, जैकोबियन वगैरह, तो यू वोंट गेट वरीड. या सिमिलरली व्हेन यू विल सी डिफरेंट काइंड्स ऑफ डिकम्पोजिशंस, तो आपको यू विल हैव एन इंट्यूटिव अंडरस्टैंडिंग ऑफ व्हाई आर दे बीइंग डन. या एंड सून वी विल यूज देम इन डायमेंशनलिटी रिडक्शन, जब वो हम मशीन लर्निंग पार्ट पे एप्लीकेशंस पे आएंगे. सो आवर next big module is the thing that complements linear algebra. Yeah, अभी तक जो कुछ था वो broadly linear algebra ही था वो सारा. So this is now a completely different story. I had mentioned there is linear algebra, probability and optimization, and in optimization the models we take are from linear algebra with uncertainties added, meaning probability added to them. So both of these come together, and the models we build with them, then we use optimization to optimize the models. और आ जाके यही वो आपकी machine learning के different statistical machine learning, deep learning आ जाके they are built on these things. So if you recall, अगर आपको याद हो, हमने ये काफ़ी पहले when we were talking about systems of equations, right? And I mentioned that although in universities, in courses, we are always talking about system is fully determined हो, rank full हो, सब कुछ हो, but in reality what we face is in general overdetermined and inconsistent systems. And I had mentioned the reason for that is natural randomness, variations in things. Yeah. So if you measure the same process 100 times, or the growth of a process, a dynamic process is growth over time, there are bound to be errors, there are bound to be variations in there, right? So now because of that, we realize that okay, what we can do is we will get overdetermined, inconsistent, or at least we'll get inconsistent systems. Then why do we go for overdetermined? Because we want to make use of the statistics to get rid of the randomness thing. Yeah. So here if we know that each of these points has some error, तो फिर किसी एक को लेने की बजाय बेहतर है we take lots of them and try the least squares, right? Minimum distance, कोई भी, there are many ways, but we then combine their information and get an average behavior, which we hope, अगर सही से हमने किया हो, would reduce the effect of the variations, right? So we saw this one also before in modeling the neural network. There were weights of the neural network. Here there were oops, I should have grabbed the pen. Yeah, so there are weights of the neural network, right? And these are acting on your observations, which, as we already said, will have random variations. So these could be pictures of 10 cars. Even if they are the same model, same maker, there will be variations, right? Even if it's the same car, आपकी ही गाड़ी है, किसी वक्त sometime it will be a bit dirty, sometimes lighting conditions will be different, sometimes angle will be a bit different, right? So we expect variations in there naturally in the observations, all that. So that's what our module is all about, probability, which is what we will look at here in the broader sense will be how do we model uncertainties, how do we collect the knowledge of these uncertainties, these probabilities. Then how do we extract key indicators from these distributions? We'll look at some common distributions, and then we'll end with the problem of estimating parameters, okay, which is definitely part of all machine learning. So as I normally ask in my courses, what is probability? आप लोग तो random process में लिया हुआ कुछ yeah. So for the rest of you, what is probability? क्या होती है? Chance of occurrence. Okay. So that is correct, definitely. But I like to call it more of a philosophical thing. Is the lack of knowledge. Yeah. Probability for me is the lack of knowledge. You are here today. Yes, you are sure. There is no lack of knowledge. So there is no need to say probably here. Right? You are here. So, but will you be here in the next lecture? Well, we are not sure anymore. There is lack of knowledge now. You say perhaps, maybe, most probably not. The probability probably comes in when there is some lack of knowledge. Yeah. Another example, you know your height. Yeah. But what's the height of the next student who enters the room? हमें नहीं पता. Right? Again, there is lack of knowledge. Now, why do we sometimes lack knowledge? क्यों lack करते हैं knowledge? क्या वजह होती है चीज़ों के बारे में? अच्छा, क्यों नहीं होती? For example, what hinders us? Let's say हम हैं सीखने वाले हैं. एक तो होता है वो आप बात सही है जिसे नहीं सीखना उसके पास तो कोई नॉलेज नहीं होगा. Let's say we are eager to learn things. Then what hinders us? क्या रोकता है? It might be hard to collect the information, right? Too hard to collect the information. Or एक भूल रहे हैं आप बड़ा सिंपल सा जो मैंने पूछा भी है, height of the next student entering. It can be a future event, and the way things are so far, अभी तक time travel नहीं invent हुआ, so future हमें नहीं पता होता, right? So it might not have happened, right? और कोई वजह ज़हन में आती है? तीसरी वजह, आप में से कोई फैन है क्वांटम फिजिक्स की? कोई नहीं है? नहीं है? बड़ा ज़बरदस्त यार फील्ड है क्वांटम फिजिक्स. उसमें क्या है वो जो वेव फंक्शन क्या है? हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल का आइडिया है. इट्स बेसिकली क्वांटम वियर्डनेस जो करंट कंसेंसस है, इट सेज दैट नेचर इन इट्स वेरी बेसिक एलिमेंट्री फॉर्म इज प्रोबेबिलिस्टिक इन नेचर. वो इलेक्ट्रॉन ये नहीं है कि it's not in one place actually, it's the probabilities of the electron wave function जो, right? So there are natural uncertainties which can never be resolved. अभी ये current ये consensus है जिसको हम Copenhagen interpretation of quantum physics कहते हैं, right? कुछ लोग कहते हैं कि just calculate it, it's enough. It says that electron is here and here at the same time, बस accept कर लो. कुछ कहते नहीं वो probabilities हैं, naturally things are fuzzy as we go deep. So बहरहाल either way I can think of at least 3 reasons that we lack knowledge. One is that the event is a future event, right? If I haven't rolled the die yet, you cannot tell its number. कौन सा आएगा? 1 आएगा. I haven't rolled it. Yeah. Another is, as you already said, this is more common. Yeah, is that it might be too hard to collect all the information. For example, which places did you visit today? Now this is not impossible. आज के दौर में especially, I could have a tiny drone following every person on earth. ठीक है? Then I can tell you कि आज आप कहाँ से होके आ रहे हैं, right? But that is just too hard. अभी तक hard है, ऐसे लग नहीं रहा, थोड़े अरसे में हो ही जाएगा. Especially our mobiles are telling them anyway now, right? So, but it used to be hard, let's say, to find this thing. Yeah. So there are many things, many systems. कोई कह रही है electronic device है, I'm trying to record the voice, and I'm gonna go up to the atomic level to find the background noise, और कर सकते हैं आप मॉडल, कोशिश कर सकते हैं, but होगा क्या, you're just putting too much effort into it, right? पूरा मॉडल इतना कॉम्प्लिकेटेड हो जाएगा कि आपको खुद समझ नहीं आएगी इसका मैं क्या करूँ, और एंड में हो सकता है वो वजह क्वांटम टनलिंग निकले जो वैसे ही रैंडम है फिर क्या करेंगे, राइट? सो another example of variations or information being too hard to collect, many mobile phones work on facial recognition. So आपका मोबाइल ये तो नहीं कहता मुझे अपनी 10,000 तस्वीरें दो, सुबह की दो, शाम की दो, दोपहर की दो, ट्रिमिंग करके दो, ट्रिमिंग के बगैर दो फिर आप कहेंगे भाई मैं नहीं करता मैं चुपचाप पासवर्ड डाल राइट? सो इट्स नॉट practical to ask for so much information, right? So third one, as I already mentioned, quantum weirdness, quantum randomness, where is the electron, current consensus, that is the nature of things. Randomness is the nature of things at the deeper level, yeah, particle level. So what is statistics? I like to call it our way of making sense of the uncertain. Now we saw that the world is going to be uncertain, yeah. There are going to be situations that haven't happened yet. There are going to be situations that are too complicated to model in their full detail, yeah. And there are going to be quantum weirdness is पूरी quantum physics built ही wave functions पे है जो कि probability functions हैं basically, right? वो उसको collapse करते हैं, chances निकाल लेते हैं, tunneling करा देते हैं, ये सारा कुछ. So what's the height of the next student who enters the room? We don't know, yeah, as we already said, there is lack of knowledge. Now this is the question which the statistics part tries to help us with. Is our lack of knowledge absolute? By that I mean, do we know nothing about heights? मतलब हमें ठीक है अगले स्टूडेंट की हाइट नहीं बता सकते, एग्जैक्ट नहीं बता सकते, बट क्या कहें, जैसे लाइक द सिस्टम ऑफ ओवर डिटर्मिन्ड सिस्टम्स, और when ax equal b was not solvable, we leave it at that, छोड़ के चले गए थे हम, नहीं, we found pseudo inverse, we found projections. So similarly here, do we say okay नहीं भाई मुझे नहीं पता अगले स्टूडेंट की हाइट क्या है, एक्चुअली मुझे नहीं पता वाकई, बट इज दैट लैक ऑफ नॉलेज एब्सोल्यूट? अगर वो एब्सोल्यूट हो, दिस होल डिस्कशन इज यूजलेस देन, right? Agar we say we have know absolutely nothing about the height of the next student, then there is no point in discussing probability theory, because कुछ कर नहीं सकते. But it seems there is hope, right? We do know something. क्या पता है हमें? So shortest person currently, tallest person, right? कुछ साल पहले की पिक्चर मैंने ली हुई है, तो मे बी इट हैज़ चेंज्ड, आई डोंट नो, बट काफ़ी चांस है कि द नेक्स्ट स्टूडेंट कमिंग इन इज टॉलर देन द शॉर्टेस्ट एंड शॉर्टर देन द टॉलेस्ट, राइट? अदरवाइज वी हैव टू कॉल द गिनीज बुक ऑफ रिकॉर्ड के जी नया रिकॉर्ड कायम हो गया ठीक है. सो लाइकलीहुड चांसेस यही हैं कि इनके बीच में है कहीं, राइट? नॉट ओनली दैट, ये तो एक्सट्रीम है ना, या नॉट ओनली दैट, वी ऑल्सो नो about typical human heights, that they follow a particular distribution, right? वो क्या होती हैं, इस तरह की होती हैं कुछ. Men are generally taller, right? Then in general extremes are rare. बहुत छोटे कद भी कम नज़र आएंगे आपको, बहुत लंबे भी कम नज़र आएंगे, मिडल ज़्यादा होता है. ये जो चांस, ये जो ऊपर जा रहा है कर्व, ये मिडल में, फॉर men it's to the right, one I don't know 175 180 सेंटीमीटर, आई थिंक ये यूरोप का लिया हुआ, क्योंकि पाकिस्तान में तो है दोनों कर्व थोड़े से और लेफ्ट हो जाएंगे. सो चेंजेस बाय नेशन, चेंजेस बाय जेंडर, ऑल दैट. सो we can see these as graphs of relative likelihood. But the point I'm trying to make is that our lack of knowledge, yes, there is probability, there is uncertainty, but the lack of knowledge is not absolute in most cases. We do know something about this situation, and we can try to make, that's the important part, some guesses based on whatever information we have. So अगर आप look around you in this room, आपको कोई guesses नज़र आते हैं जिन पे कुछ बना हुआ हो, कोई डिज़ाइन हुआ हुई चीज़? इस रूम में? Do you see anything that has been designed based on the guess? उनको तो नहीं पता था कि यहाँ आगे कौन बैठेगा, right? They don't know कि इस डोर से किसने पास करना है, फिर भी बनाया है ना, right? तो डोर जो है आपका इस हाइट का क्यों नहीं बनाते हम? क्यों पता है मेजॉरिटी को मसला होगा, राइट? यस, सो वी हैव ऑलरेडी मेड, ये रूम भरा हुआ है डिसीजन से, ये जो इसका साइज है, इसकी जो चेयर की हाइट है, सीट की हाइट है, डेस्क की हाइट है, all of that has been designed so most humans will be comfortable, right? उसके बाद of course you might say okay इसको और बड़ा कर दें, तो that's a waste of resources, right? So you try, अभी इसमें भी कई लोगों को अगर यूरोपियंस आ जाएं स्पेशली तो उनको बेंड होके ही आना पड़ेगा, वेरी टॉल पीपल अराउंड, या स्टिल overwhelming majority of humans can pass through here. So this door already has a statistical decision in its design, right? So we do make a lot of decisions based on statistics, although there is lack of knowledge. तो हम ये नहीं कहते मुझे एग्जैक्ट नहीं पता हाइट तो मैं अब दरवाज़ा नहीं बना सकता, पता नहीं किसने गुजरना है हाथी तो नहीं गुजरने, right? So you design for whoever you're working for and based on their statistics, right? So statistics helps us make smart guesses about uncertain events. Why do we want to make smart guesses? Because we want to plan, design or take steps to better control the situation. तो हम ये कहते हैं ठीक है, I'm not sure about it, but that doesn't mean I give it up entirely. Whatever information I have, I'll try to make smart design choices based on that information, right? So now how do we assign probabilities? There are two ways of looking at it. We assign probabilities through repeated experimentation, observation, बड़ा specific तरीके से कोई data लेके. We also often assign probabilities through some belief, मतलब मुझे पूरा यकीन है कि वो नहीं आएगा या हम कहते हैं ना हमें पूरा यकीन होता है या so there is a lot of belief in many things that we do. So there are two philosophies of probability theory itself कि होती क्या है. The more commonly used जो पढ़ाई भी जाती है वो frequentist, but for our purposes the more useful one often is the Bayesian. Yeah. So what's the difference? ये philosophical है, इसको आप काफ़ी देर भी पढ़ते रहें तो शायद आपको समझ ना आए, ठीक है? But I'll try to very briefly mention some of this, then things become clearer when we see their formulae. So probabilities, Frequentist says probabilities can be found by a repeatable objective process, and there is no need for opinion in it. So they say repeat the experiment many times, yeah, and you can find the probabilities. Inferences are based on data only. Compared to this, if you look on the right in Bayesian, it says that probability expresses a degree of belief in event. Yeah, the belief may be based on prior knowledge or previous experiment or on personal belief about the event. Okay. Inferences are based on data only in Frequentist. In Bayesian, inferences are based on both data and prior belief. In Frequentist, hypotheses are tested and declared true or false. Okay? They just have a very clear decision कि ये true था या false था. In Bayesian, we assign probability of being true or being false. 90% chance है कि ये true है बात and 10% chance है ये गलत है, ठीक है? जबकि Frequentist just decides. In practice, how does it work? Frequentist says take as much data as you can. पहले ले लें सारा data. Experiment को बड़ा clearly define कर लें, get all the data and use it to make the guesses, inferences. Whereas Bayesian says make a first guess of what to expect. That's where the belief thing comes in. Then update the guess based on new data. Okay, so we will see the Bayesian formula also, yeah, today. So we'll get a better idea. The good thing about Bayesian approach is that it naturally allows learning cycles, because it says okay, let's start with whatever prior knowledge we have about the event. Let's make a prediction, bring in the data, check if our prediction is different from what we saw, update our knowledge, and now that new knowledge becomes our, even here they don't stop. They say, well, at any given time, whatever we think we know is the current state. When new data comes in, we have to update our knowledge, right? So ये आपको बहुत clearly machine learning ही लग रहा होगा, वो भी यही करता है ना, yeah? So you have initial data, you make predictions, you compare it to the what new data or what data you want to you expect to see, you see the error, and you update the parameters, right? So assigning probabilities, well, I'd say it's usually a 4-step process. It's not fixed thing. You could write it in different ways, but how do we assign probabilities? Firstly, clearly define your experiment. ये बहुत important होता है. Experiment doesn't mean कि आप lab में बैठे हो, right? It means जो भी आपका setup है, जिसमें आपने probabilities assign करनी है. You have to define that very clearly, like rolling a 6-sided die, tossing a coin, picking a student and random from a class. Make it very clear, अपने experiment को, अपने setup को. That's the first thing. Second, define the sample space. What's a sample space? It's the set of all distinct possibilities in your experiment. Now, that also shows you it's important to clearly define the experiment. क्योंकि अगर आपका वो clear define नहीं है तो आप उसकी सारी possibility clearly define नहीं कर सकते, right? You will miss some of them, or you may add some which were never possible. Yeah. So for rolling a die, Ludo वाला जो die होता है, so the set of possibilities is what? 1, 2, 3, 4, 5, 6. अब मेरे घर में एक 12-sided die भी है बड़ा वाला. Yeah. So experiment has to be clear, right? 6-sided die है. Yeah. So 12-sided है, कितने sided है सारा कुछ. अगर वो 12-sided होता तो the sample space फिर क्या होगी? 1, 2, 3, 4, 5, 6 up to 12. Yeah. So yeah, clearly define your sample space. Define events of interest. उसमें आपकी क्या है interest की events? इन्हीं के अंदर से होंगी वो. Of course, they have to be in this omega, right? Because the omega contains all the distinct possibilities. So they can be one of those possibilities, it can be a collection of those possibilities, but it has to be in here, right? So define some event, some outcome of interest. Event, we could also define it as a subset of omega. Being a subset, it could be null or all of omega. Yeah. So what's the probability that I roll a die and I see a number between 1 and 6? Right? That event is omega. Yeah. So what's the probability that I roll a die and I don't see any of these numbers? That's the null. What's the probability that I roll a die and I see an even number? अब even number वैसे क्या होगा? 0, 2, 4, 6. लेकिन इस experiment में क्या रह जाएगा? 2, 4, 6. Although even number चलते जाते हैं, लेकिन इस experiment के अंदर it's only 3. Yeah. So that's here. You could define a general event as omega in omega such that omega satisfy, और ये set है. So you don't have, you're not restricted to one omega. Like I say omega such that omega is even. So for the rolling die experiment, A would then automatically, you build a notation है ना set की. So A will be then 2, 4 and 6, because these are the 3 omegas inside omega that satisfy my condition of being even. Yeah. So lastly, assign probabilities. By that we mean, mathematically we mean assign real numbers to events such that the assignment scheme, which we will call probability measure, makes sense. याद है हमने जब vectors की measure लिया था, उनका norm जो लिया था, size of the vector, we said it has to make sense. So we defined some rules for what we will call a metric. what we will call a distance metric, what we will call a norm, what we will call an inner product. बड़ा प्रिसाइज हमने डेफिनेट, ताकि वो उसकी सेंसिबल मीनिंग हो. ऐसे ही था ना, उसके रूल्स थे, एक्सियम्स थे. सिमिलरली हियर वी विल हैव एक्सियम्स ऑफ probability. So the fourth step, first your experiment setup should be very clear. जब वो क्लियर नहीं होगा तो आपका दूसरा स्टेप वैसे ही गलत हो जाएगा, सैम्पल स्पेस ठीक नहीं डिसाइड. Secondly, decide this set of all possibilities distinct, or that we call the sample space. Omega लिखते हैं ना. Define events of interest. Assign probabilities to events such that the assignment scheme makes sense. अब याद है नहीं था एक्सियम क्या होता है, समथिंग वी डोंट प्रूव, इट्स बस लॉजिकल होता है, राइट. सो इधर भी प्रोबेबिलिटी का भी लॉजिकल है. नाउ कैन एनीबॉडी गेस के प्रोबेबिलिटी के एक्सियम्स कब लिखे गए? आपको तो पता होगा लेकिन बाकियों गैस करें. गैस करें किस दौर में लिखे गए होंगे? एक्सियम्स ऑफ प्रोबेबिलिटी विच डिफाइन प्रोबेबिलिटी मेजर. 100 साल पहले, 200 साल पहले, 300 साल पहले, ज़्यादा है ना, यही लगता है ना. 1933 में लिखे गए. प्रोबेबिलिटी थ्योरी इज़ अ बेबी कंपेयर टू रेस्ट ऑफ द मैथ. सही है. पहले इससे जो ज़्यादा यंगर बेबी है वो गेम थ्योरी होगा शायद, बाकी या वो केओस थ्योरी वो मज़ीद इसके बाद है. वरना ये बिल्कुल 1933 कुछ भी नहीं है. 3000 साल पीछे तो लीनियर अलजेब्रा और जियोमेट्री चल रहे यार, मतलब लीनियर अलजेब्रा तो नहीं लेकिन जियोमेट्री फिर 2000 या 1500 साल पीछे तकरीबन अलजेब्रा आ जाता है आपका. सो द एक्सियम्स ऑफ प्रोबेबिलिटी, पैस्कल ने ऑलरेडी 400 साल पहले आइडियाज़ तो लगाने शुरू कर दिए थे, बट इट वाजंट मैथमेटिकली एक्सियमेटाइज्ड. इसकी मैथमेटिकली फॉर्मल नहीं हो रही थी, बस अंदाजे थे, गैसेस चल रहे थे, गैसेस में गैसेस चल रहे थे. या सो किसने लिखे थे? रशियन मैथमेटिशियन Kolmogorov. He wrote the axioms of probability. These are the rules that make sense to us for a probability measure. Yeah. So what are the three rules? बताएं आपको, right? Probability should not be negative. ठीक है. Likelihood है ये shouldn't be negative. Probability of the sure event should be 1. Otherwise आपने कुछ मिस कर दिया. ऐसे ही है ना. आप कह रहे हैं कि ये दिस इज़ दी सेट ऑफ ऑल पॉसिबिलिटी. सेट ऑफ ऑल पॉसिबिलिटीज़ की प्रोबेबिलिटी तो फिर 1 होनी चाहिए, राइट. 100% होनी चाहिए. प्रोबेबिलिटी ऑफ म्यूचुअली एक्सक्लूसिव इवेंट्स शुड मेक सेंस, which is that it should be you should be able to write it separately as their sum. There should be no other term, क्योंकि वो म्यूचुअली एक्सक्लूसिव है. So there should be no term where you have probability A union B, probability A intersection B. तीसरी टर्म नहीं होनी चाहिए इसके अंदर, राइट, क्योंकि वो हैं ही अलग, तो उनकी प्रोबेबिलिटीज़ जो जो अलग निकलती हैं वही सम हो जानी चाहिए. सो दीज आर एक्सियम्स, इसको प्रूव नहीं करना हमें. दे मेक सेंस. जैसे नॉर्म्स में था ना, नॉर्म का वो उसमें जो ट्रायंगल इनइक्वालिटी नॉर्म हैज़ टू सेटिस्फाई, दैट मेक सेंस टू अस, उसको हम प्रूव नहीं करें, राइट. सो first one, as you see, is saying assigned probability should not be negative. Second one is saying assigned probability should add up to 1. Sure event बनता है जब तो they should add up to 1. Third one is saying probabilities should for mutually exclusive events that by the way mutually exclusive event क्या होते हैं, which cannot occur at the same time. Yeah, you know that. Should make sense, which is this. If there are infinite number of possible mutually exclusive events, then we replace this axiom 3 बाय दिस एक्सियम. ये लिखा 4 हुआ है लेकिन रहते 3 ही हैं, बस वो उसको रिप्लेस कर देता है अगर इन्फिनिट केस है आप पास, विच इज़ अगर आप इसको पढ़ेंगे तो इट्स जस्ट द इन्फिनिट वर्जन ऑफ दिस लास्ट वन. या तो ये सिंबल पता है ना सेट यूनियंस का, जैसे समेशंस होती हैं ना आपकी, तो ये यूनियन ऑफ A1 A2 A3, A1 यूनियन A2 यूनियन A3 यूनियन, ये वो चल रहा है. सो So formally speaking, what is a sample space? ये ओमेगा है, yeah, the set of all possibilities अभी हमने कहा है इसको, but more formally it is a mathematical abstraction of collection of all possible experimental outcomes determined by omega. The objects inside it, its elements are called sample points, जैसे omega 1 omega 2 वगैरह. Each sample point therefore corresponds to a possible outcome of a real world experiment, right. So, that is sample space. This is Kolmogorov probability measure. What is a probability measure? Basically, it is an assignment of real numbers to the events in omega. आप वो assign करते हैं, and those assignments should follow the axioms of probability. And as this just a bit of history, 1933 में publish हुआ ये, that's very new, 100 साल भी नहीं हुए right. So let's look at some terminologies and results related to events. Events याद है, the subset of omega जिसमें हमें कोई इंटरेस्ट है या कोई हम उसका करना चाहते हैं. So firstly, events come from the sample space. So sample space is the set of all possible distinct events. Yeah, ये सारी rolling a die में क्या होंगे यहाँ पे 1 2 3 4 5 6 या distinct हैं सारे, वो mutually exclusive होने चाहिए इसके अंदर जो पड़े हुए हैं, right. Each one we will call a sample point because it's coming from the sample space. Yeah, simple event, an event containing only one sample point, we will call that a simple event. A compound event on the other hand will contain more than one sample points. Null event contain no points. Yeah. So sure event, an event containing all the sample points. So C is, and if you define an event C as omega, you have covered everything. So that is the sure event. Equally likely events, events having the same probability of occurring. So if there is an event A and there is an event B, and if PA equals PB, then we say that these events are equally likely, they have the same probability of happening. Mutually exclusive क्या है, ये आप पता है ज़्यादातर चीज़ें, या events that cannot occur at the same time. So if A is omega 1 omega 2, जो events हैं, जो compound events हैं, they are always built on the simple events, right. So A is built on omega 1 and omega 2, B is built on omega 3 and omega 4. जो भी इतने आप subset उसके overlapping, non overlapping, null, omega, जितने subset imagine कर सकते हैं, all of them can be your events. पर सारे आप define नहीं करते, मतलब you only define the ones जो आपके interest के होते हैं, right, वरना तो वो लगे रहेंगे आप. Yeah. So events that cannot occur at the same time, mutually exclusive है. Sets में ये होगा कि उनका जो set है that will be disjoint, A intersection B will be null, so probability for the null will be 0, that means they cannot occur at the same time. Complement of an event are all the events in omega that are not in A. Yeah, so event A, whatever event A comprises of, the complement comprises of all the events other than that. So for example, if A is, if I roll a die and I say A is even number showing up, so the A is 2 4 6, then what's the complement of A? Odd number showing up, because together they form omega, right. So that is the complement. Union of events, you know that, right. A union B is simple events omega such that omega belongs to both, to A or B. Yeah. So it's a union, जैसे set की union होती है, अब ये events की union हो रही है. And यहाँ पे कुछ interesting इन्होंने results वैसे भी show किए हुए हैं, A union, De Morgan's law वगैरह, intersection to when omega belongs to both A and B, we know that, and again we see some commutative laws, associative laws, distributive laws, पता है जो set में होते हैं वही हैं सारे. Yeah, but now we see the elements as simple events. A, B, C के अंदर जो elements हैं वो क्या हैं? Simple events. They are coming from the sample space. Yeah. So De Morgan's laws मशहूर हैं, A, U, B complement, ये सारे वो analytical solutions में काम आते हैं. Yeah. So we know this. I'll just go. Joint probability. अभी हमने एक probability of an event A को assign की, but we are often interested in finding probabilities of two events occurring at the same time, and we call that the joint probability. So इसको हम क्या कहेंगे, probability A and B और probability A intersection B और probability AB. कई तरीके हैं इसको लिखने के. Let's say Ali is in lecture, Ali is sleeping, then probability A and B is probability that Ali is sleeping in the lecture. Yeah, so hopefully there's no Ali here. है तो नहीं? No, slides change करनी पड़े. Right. So another example, die shows even number, die shows greater than 3. Right. So probability of A and B is probability of getting an even number above 3. Of in our sample space that leaves only 4 or 6. Yeah. So conditional probability. Now sometime knowledge of one random event can help us assign probability to another random event. Now that's where conditionals come in handy. So Ali is in lecture at 8 a.m., B Ali is sleeping at 8 a.m. Now suppose I tell you that A has occurred, that is Ali is in lecture at 8 a.m. and I ask you what is the probability that he is sleeping with this new information. This is what we write as probability A given B, and we write it like that, A is line B. That is low of course but not 0. अगर ये information ना दूँ तो हो सकता है आप सोचें हाँ सो रहा होगा कमरे में, but as soon as I give you that information, मतलब sleeping के chances 0 नहीं हो जाते लेकिन still low हो जाते हैं. So understanding conditional probability, what really happens. So let's see from a थोड़ा ज़्यादा clearer experiment, या वो sleeping वाला तो ऐसे शुगल में. Suppose that I tell you that I have written an integer from 1 to 4 on a piece of paper, but do not tell you the number. Yeah, ये मैंने अभी जो ऊपर किया ये probability assignment का कौन सा step है, पहला, clearly define your experiment, right, or your setup. So समझ आ गया. I take a piece of paper, I write a number on it from 1 to 4, integer. Yeah, and I well, I don't tell you the number. Under the assumption, अब ये देखिए आप belief आएगा that I could have picked any of the 4 numbers with equal chances. हो सकता है I am someone who always picks even numbers. हो सकता है ना, लेकिन अक्सर हम देखेंगे आप experiments में हम इस तरह का belief डालेंगे कि नहीं नहीं सब का chance बराबर है. पता नहीं क्यों, मतलब mostly इस तरह होता है. So that I could have picked any of the 4 numbers. What is the probability that I wrote 3 on it? So क्या है probability? Now the event is A is that I wrote 3, right? Sample space क्या है? 1, 2, 3, 4. Yeah. So I am asking for probability of one of them, 3. क्या हो जाएगी? 1/4. अगर वो belief हम ना डालें फिर आप नहीं कह सकते, right? अगर आप डालेंगे नहीं I am someone who is twice as likely to pick an even number than an odd number, तो फिर ये change हो जाएगा already. Yeah, but normally we add those beliefs. So we often don't even mention that belief. Anyway, probability of A is 1/4. Now suppose I tell you, that is I give you new information, that I wrote an odd number, मतलब along with that information जो पहले दी हुई है मैंने कि I wrote an integer from 1 to 4. I give you that I wrote an odd number. Yeah. Now what is the probability that I wrote 3? Yeah. So it's 1/2 now. Why is that? Now what's the new information? That I told you that this has happened because I said I wrote an odd number. Now within this sample space there are 2 odd numbers, 1 and 3. So what is the probability of A given B? The probability of A before this information was 1/4. Will it change after this information comes in? In this case it does and it becomes 1/2. Yeah. So as you said, now what has happened here? Let's look at it. Very interesting thing. What just happened here? This is the sample space before the additional information. Before I told you that I wrote an odd number, what was the universe of possibilities? It was 1, 2, 3, 4. What happened to this universe as soon as I gave you this new information? This universe shrank. Shrink हो गई है, ऐसे ही है ना? It shrank, it became this one, sample space after this additional information, and that led to the probability changing, yeah, becoming more accurate. So what does that show us? That clearly a relevant piece of information has shrunk the sample space, leading to a more accurate assignment. ये ज़्यादा असाइनमेंट का मतलब ये नहीं कि probability increase होगी, मतलब हमें नहीं पता एक्चुअल probability क्या है उसकी, इंक्रीज नहीं होगी, जरूरी नहीं कि वो 1/4 से ऊपर ही जाए, जो भी आएगी बहरहाल वो ज़्यादा एक्यूरेट क्लोज टू द ट्रू वैल्यू होगी. ओके, सो but there is a important word here that I will come back to very quickly soon, relevant piece of information, yeah, वो भी देखते हैं हम. Now what if the additional information I give you is I wrote a positive integer, or I had cake for breakfast, which I didn't, but anyway, yeah. अब अगर मैं ये information आपको देता हूँ, now what is the probability that I wrote 3? Yeah, that is probability of A given C. उस information से कोई फर्क पड़ेगा इस वाली से? नहीं पड़ेगा. Shrink होगी space आपकी? नहीं होगी, right? So this new information is useless, ऐसे ही. और this new information is actually very much irrelevant. इसका कोई ताल्लुक ही नहीं है उस बात के साथ, ऐसे ही. Unless मैं आप बताया हो कि मैं केक खा के ऑड नंबर ज़्यादा रेगुलरली चूज़ करता हूँ, उसके अलावा तो कोई वजह नहीं होगी. सो these are two situations. Here was a situation where the probability of A changed after there was new information. So it from before without any new information it was 1/4. With the new information it changed to 1/2. But here in these two cases we realize that we don't have to calculate it. We already know that probability of A given this information is still the probability of A. कोई मुझे फ़ायदा नहीं हुआ उसका. Yeah, that is where the word relevant come in. The two pieces of information are quite useless or irrelevant in the sense that they fail to shrink my sample space. तो मुझे कोई फ़ायदा नहीं होता उसका. Yeah, so the sample space before this information came in and after this information was exactly the same. So probability A given C is still the probability of A. So we will soon use that to define a very important concept. But before that let's see, अभी हमने कौन सी probabilities दो देखी हैं? Joint, probability A and B and probability A given B. फ़र्क पता समझ आपको and में और given में क्या है फ़र्क? अच्छा, right. So I like to look at it this way, that in the AND thing both A and B are random. दोनों का ने होने का चांस है, अब नहीं भी है. जबकि A given B में B is no longer random. It I am saying either I am assuming, या मैं आपको कह रहा हूँ आप मान लें इसको, या हो मैं आपको एविडेंस दे रहा हूँ, B has happened. So B is no longer random. B A and B में both are still open, both are random. Yeah. So वो बात आपकी सही है उस तरह भी. You can look at it. So there is a very nice link between the conditional and the joint probability, which is well known that probability of B given A is probability of A and B divided by probability of A. Of course mathematicians would immediately say that PA cannot be 0. Less than 0 क्यों नहीं लिखा या not equal to 0 क्यों लिखा? Because probability by very axioms cannot be negative. Yeah, so it has to be not just non-zero, it has to be positive. Now इसकी कोई लॉजिकल रीज़न आपको, ये तो मैथमेटिकल रीज़न होगी ना, ये तो नज़र आ रहा है अगर पी ए इज़ 0 दैन इट्स डिवीजन बाय 0, वो तो मैथ ही कहता है कि नहीं होना चाहिए. लॉजिकल रीज़न कोई समझ आती है आप क्यों नहीं अलाउ होगा ये? नहीं, नेगेटिव की बात, पी ए इक्वल टू 0 क्यों नहीं हो सकता? हम कह रहे हैं ना ग्रेटर का मतलब ये है कि सिंस इट्स पॉजिटिव सो वी सेइंग ग्रेटर देन 0, बट व्हाट वी आर सेइंग इज दिस कैन नॉट बी 0, राइट? फ्रॉम मैथ इट्स वेरी इजी टू सी. मैथ कहता है कि डिवीजन बाय 0 आ जाएगी, या बट लॉजिकली कोई समझ आती है? आप अगर मैथ को साइड पर रख के सोचिए क्योंकि अगर आप मैथ की लॉजिक नहीं देखते ना फिर नहीं फ़ायदा होता यानी हो सकता है आप बड़े कोई रिगरस फार्मूले निकाल लें कोई नए, लेकिन स्टिल कोई आती है समझ? नहीं, हमें है इन्फॉर्मेशन कि इट्स एन इम्पॉसिबल इवेंट, राइट? ये बड़ी अच्छी बड़ी ज़्यादा इन्फॉर्मेशन है ये तो, कि वो हो ही नहीं सकती थी नहीं, प्रोबेबिलिटी ऑफ ए ज़ीरो का मतलब है कि इट्स एन इम्पॉसिबल इवेंट, एग्जैक्ट प्रोबेबिलिटी हम उसको दे रहे हैं, इट्स एज क्लियर एज वन। आपको पता है अगर आप दोनों का श्योरिटी लेवल बराबर है, वन का मतलब है कि ज़रूर होगी, ज़ीरो का मतलब है बिल्कुल नहीं होगी, ये तो बिल्कुल दोनों बराबर लेवल है ज़ीरो से कोई ये ना समझे कि वो कह रहा है कि हमें पता नहीं है, वो एग्जैक्ट कह रहा है आपको कि ज़ीरो है अच्छा चले मैं इस तरफ बताता हूँ। When we say that find the probability of B given that A has occurred, ठीक है, I asked you to find this, ठीक है, then I tell you, जब आप फाइंड करने की कोशिश करते हैं, अब ये जुमला ज़हन में रखना है आपने, आई एम सेइंग फाइंड द प्रोबेबिलिटी ऑफ B given that A has occurred, ठीक है, then you ask me, okay, to calculate this please tell me what's the probability of A occurring, I say it can never occur, ठीक है। अब मेरे सवाल में और मेरी जो इन्फॉर्मेशन है उसमें कंट्रास्ट है। सवाल क्या है? प्रोबेबिलिटी बी गिवन दैट ए हैज़ अकर्ड, बट नाउ आई से सॉरी ए कुड नेवर हैव अकर्ड, तो वो सवाल ही लॉजिकल है, ऐसे ही है ना? दैट देयर इज एन इंटरनल लॉजिकल इनकंसिस्टेंसी। आई एम सेइंग प्रोबेबिलिटी बी given that A has occurred, but then when you ask me what's the probability of A, I go, oh no, it can never occur. And why would, how can I find the probability of B given an impossible event has occurred which is never going to occur, right? So yeah, so I've written that down here. अज़ान हो रही है। राइट, ये समझ आ गया आप पॉइंट? या सो statistical independence, this is a very important concept in probability. We have already touched upon this in this sense, when knowledge of one event does not change the probability of another event. मतलब कोई फ़र्क ही नहीं पड़ता कि मुझे ये इन्फॉर्मेशन पता है या नहीं पता, समझे कि वो दोनों चीज़ें आपस में इंडिपेंडेंट है, राइट? बिकॉज नोइंग द अदर वन does not help me know the first one better. Yeah, so that is called statistical independence. In that example when we saw, I said wrote a positive integer, but the information I already had was already covering this, so this information was useless. So probability of A given C was the, that this is actually saying that आप मुझे C बताएं ना बताएं कोई फ़र्क नहीं पड़ा. The probability I was going to assign to A is still the same क्योंकि it didn't shrink the universe of possibilities. So as I've already shown you, before the information and after the information, the sample space is exactly the same. In other words, two events are statistically independent when knowledge of one adds no useful or new information towards possibility of the other. So this is the actually the primary test for independence. Two events are independent if probability of A one given the other is the same as before. Yeah, so इसको आप उसी तरह read करें कि knowing B has not helped me with the probability of A. जो पहले थी वही अब है, तो फिर B का मुझे क्या फ़ायदा? That means B has no bearing on A, उससे कोई relation नहीं है उसका, at least statistically. Another test that we often use is this one, which is two events are independent if their joint probability is separable. ठीक है, वैसे नहीं होती है. याद है वैसे क्या था? Probability of A and B was in terms of probability of A given B times probability of B, वो जो formula. But if they are separable, then these are ये test कहाँ से आया? It comes from this formula. Probability of A given B is this. If you plug in probability of A given B equal to probability of A from here, first test है तो you get the, so the tests are equivalent. दोनों test same चीज़ देते हैं. So some examples and consequences of the axioms. बस थोड़ा सा और करके फिर ब्रेक फिनिश कर देते हैं. फिर नमाज का भी कल फिर थोड़ा सा लंबा कर लेंगे लेक्चर. So maybe 2-3 more minutes. Given the sample space omega containing 6 simple events, can you find P omega 1? So there is I give you a sample space omega. It contains 6 simple events. मैंने ये नहीं बताया experiment क्या है वो कैसे, बस ये बताया. तो is P omega 1 1/6 है या नहीं? Sure. अच्छा. आप एक assumption डाल रहे हैं इस वक्त. वो क्या assumption? To get this 1/6. हाँ, आप ये assumption डाल रहे हैं, मैंने तो नहीं कहा. देखिए simple event का ये मतलब नहीं है कि उनकी probability भी बराबर है. Some simple events can be more likely than others. As I said, अगर 1 2 3 4 पे लिखना और I am a person who mostly writes even numbers, so then although 1 2 3 4 are all simple events, 2 and 4 are more likely. तो आप जो कह रहे हैं वो possible है under an assumption, otherwise you cannot answer this question. इस वक्त आप answer नहीं कर सकते. Yeah, so it's kind of a trick just to make sure that you understand. Okay, if you want to bring in the belief, then it should be very clear. We cannot claim this unless we have more information or are ready to assume that information or justified in assuming that information. And that all simple events here are equally, if you assume they are equally likely, then in that case, yes, 1/6, right? Otherwise, no. Another example, let's say we have a sample space omega containing 4 simple events, and I give you the information that omega 1 is, omega 2 is 1/5. Omega 4 निकाल सकते हैं आप. So from the axioms say the whole sample space का जो है वो sum 1 होना चाहिए. These are mutually exclusive events, so इनका sum जो है वो 1 होना चाहिए. When you find that, solve it. So 1 2 3 4 का sum should be, is the sure event, should be 1. If you calculate that, you can find it to be 2/5. Now are these events equally likely? No. 3 of them are. 3 हैं जो equally likely हैं. चौथी जो है वो twice as likely as each of them, right? In this scenario. So how do we establish in practice whether events are equally likely or not? There are 2 ways. One is we either assume जैसे मैंने कहा I wrote a number from 1 to 4, then in general we'll assume that all 4 numbers are equally likely. Mostly ये होता है. Other ways it could be that you're calculating and P of A and P of C and you find that the actual values come out to be equal. Then you will say they are equally likely. Yeah. इस पे फिर कल आते हैं इंशाल्लाह. ठीक. So we'll finish here.